Good morning, everybody. Today's January 12th, and I apologize I wasn't able to be in class with those of you that are watching this. But I figured, you know what, I better just make sure that you guys can stay up to date. I am unfortunately quarantining, so all right, let's go ahead and get started. We're going to move on today to proving parallelograms using sufficient conditions. Now, there are four such conditions that will help to prove that that it is a parallelogram or whatever it may be. And obviously, in those, in a parallelogram, you're going to have to know the properties. So we're going to get into those here in just a moment. So just as a reminder for proofs, you cannot use the statement that you are trying to prove as a reason ever. So like if it says prove angles A and B are congruent, you cannot be like, oh, well, that's step 2. That's got to be at the very end. You should always end the statement with what you're proving, as I just mentioned, and a reason that follows from your previous statements. You can never assume that 2 points or sides are congruent or parallel unless you have been told that or able to prove it based on another statement. So I know yesterday in class we talked a lot about with triangles and like the outside edges and trying to prove those. Unless they've actually been shown or they have the markings to prove that those sides are congruent, you cannot use those, right? So you have to be able to prove it. Remember, I keep talking about it, but it's not going to go away. You have to think and consider. It's like a third grader always asking why. You have to be able to explain yourself. So let's talk about the sufficient conditions before we get into these couple proofs. In a parallelogram, if in a quadrilateral both sides of opposite sides are are parallel, then it is a parallelogram. Okay, so if they give you if they give you a shape, both sides of opposite sides are parallel, then you know it's a parallelogram. If both pairs of opposite sides are congruent, then you know it's a parallelogram. Okay, so if this side's congruent and these are congruent, it's also a parallelogram. Okay, both pairs of opposite angles are congruent, then it's a parallelogram. So this one and this one, and this one and this one, right? And then, let's see, if the diagonals bisect each other. Then you know it's a parallelogram. So again, that's probably going to be more of a rectangular shape, of course, right, where they bisect each other because it goes from this corner to that corner, and then same here, and they're even on both sides. Okay. If one pair or opposite sides are both parallel and congruent, then that is also a parallelogram. Okay, that's not what was supposed to happen. I don't know why it's not. There we go. Okay, like that. So if one pair of opposite sides are both parallel and congruent. So if any of these conditions are true, then it is a parallelogram. So that's all you have to do to prove that it is a parallelogram, is just that any of these examples are true. Okay, or conditions. So let's go through some example problems. Are you given enough information to determine whether the quadrilateral is a parallelogram? If so, explain why. So number 1, the opposite sides are both parallel and congruent. So yes, because one pair of opposite sides is congruent, and parallel. Okay. Number 2, diagonal. This one's congruent to this one. This one's congruent to this one. So they're bisecting each other. So yes, this is also a parallelogram because the diagonals are bisected. Okay. Number 3, Opposite sides are congruent, so this is also a yes. This is a parallelogram. Okay. Number 4, one side is congruent, the other one is parallel. No, we don't have any sufficient conditions that prove that. Now, if they're both opposite sides were congruent, then that would work, but this one's not. How about this one? So we have a congruent angle, right? And congruent angle, which means that if these angles are congruent, that's AIA, right? Alternate interior angles. Well, that means that these have to be parallel lines. If those angles are congruent, so yes, opposite sides are parallel. So it has to be. Okay, and then last one here. In a quadrilateral, it has to add up to 360 degrees. So this is 120. This is 120, which means this has to be 120, which means, yes, the opposite side or opposite angles are congruent. So this is also a parallelogram. So again, those are just looking at examples where we're trying to determine, do we have enough information to prove that those are that those are parallelograms. And as long as it has one of these sufficient conditions from up above, then it is a parallelogram. So the only example in this case that was not, or that we didn't have enough information, was number 4. Every other example actually had enough information to prove that it is a parallelogram. Okay, so now we're going to go through some proofs, and as you can see, nothing's written in here, which is fine. We're going to go through this together and just prove, different components based on the fact that we're using sufficient conditions. So the sufficient condition number 1 says both pairs of opposite angles are congruent. So that's the proof. It wants to prove that AC is congruent to BD. Okay, well, if it's a parallelogram, then that should be the case, right? But we're going to prove why that is the case. All right, so always start with your given. So number 1, ABCD is a parallelogram. Okay, and we know that because it is given. It's right up here. Okay, so if it's a parallelogram, then obviously the parts should work as well. But if you look at a parallelogram, you can see that this is made up of 2 triangles. So if we can prove that these 2 triangles are congruent, then we can say that their individual pieces are congruent, right? Same thing we did before. So let's go ahead and state down here, this is our endpoint. So there are actually going to be 6 steps here. Not that you would know usually, you could just put that down. But we're going to say that angle A is congruent to angle C, and angle B is congruent to angle D because of corresponding parts of congruent triangles are congruent. So this is what we talked about in class and yesterday, and going through those definitions. So once we prove those triangles are congruent, all their individual pieces will be. Okay, so working backwards, okay, we know the step before that is going to be that the 2 triangles are congruent. So triangle, ABD is congruent to triangle CDB, which is up here. So ADB, CBD, okay, and then we just have to figure out why. All right, so if it's a parallelogram, that means, by definition, these opposite sides are parallel, right? So, by definition, that tells you that these angles are congruent, okay, using alternate interior angle theorem, okay? So, that can be part of our proof. However, if we want to prove that 2 triangles are congruent, 2 angles being congruent is not enough. but they share this line in between, and we talked about this property in the notes yesterday. If they share this line in between, that is called reflexive property. So now we have enough information to prove that these two triangles are congruent and that their individual pieces are. So we have an angle, a side, and an angle. So angle, side, angle. Oops, I didn't mean to write a different color there. So that's how we know the triangles are congruent. Now we just have to state above, what are the reasons that we know that? Well, it's pretty easy. The line in the middle is BD. We know it's congruent to itself because, as we mentioned yesterday, reflexive property. Okay, then we also just said that those angles on the interior are congruent, right? And we know that because of alternate interior angle theorem. And I'm fine with the abbreviations here. That's perfectly fine with me. So alternate interior angle theorem. So what angles would that be? Well, those angles would be, let's see, if we go with the red angle first, that would be CBD. And angle ADB. Okay, then if we look at the blue, so these two, CDB is congruent to angle ABD. ABD. And there you go. Proof filled in. Again, I think the easiest way to work through proofs is to try to work backwards, think about your reasonings behind them, and then fill in the blanks, right? So that's proving sufficient condition number one, that opposite angles are congruent because the corresponding parts are congruent triangles. Now, obviously in a parallelogram, we know that this is the case, that we know that that's true, right? But this is the original proof that says here's how we know that this is in fact a sufficient condition of a parallelogram, because a parallelogram has two congruent triangles and their individual pieces are congruent. So we just proved sufficient condition number one is actually true. So now we're going to prove that sufficient condition number two is true, that makes up a parallelogram, so that both pairs of opposite sides are congruent, right? And so in order to do that, again, we have to look at the actual statement, what it's asking for, what it's given us. So first of all, it gives us the ABCD is a parallelogram. Okay, so that's what's given. All right, and this one's got 6 steps as well. And again, we want to prove right here that BC is congruent to AD, and AB is congruent to CD. And then we just have to figure out why. Oh, that's right. We already talked about it. Because corresponding parts of congruent triangles are congruent. So we are going to prove again that these triangles are congruent. And then if they are congruent, then these two sides have to be congruent, right? Or the 4 sides. All right. So let's prove this triangle. I would argue, guess what? Same thing. Okay, we have reflexive. Okay, we have alternate interior angles, right? Because we know that this is a parallelogram. So in a parallelogram, you know the properties. A parallelogram has opposite sides that are parallel, right? So disregarding every other property, we know that these are two parallel lines that are cut by a transversal. And so if they're cut by a transversal, that means that they have alternate interior angles that are congruent. Okay, so same thing as before. In fact, I would even argue, to save time, you could do this because it's the exact same image. Okay. Oops. That ain't gonna work. There we go. Okay, so again, proving that the triangles are congruent. Inside triangle, outside triangle. You have alternate interior angle theorem for the both. You have the fact that BD is equal to itself because it's reflexive. So sufficient condition number 2, again, by proving the triangles are congruent, we can say that opposite sides are congruent. So what's the point of all these sufficient conditions? It's because later on, as you continue working on proofs, if this statement is true, then you can say definitively that it is a parallelogram. So the reason why we did these two proofs is just to prove that these conditions are true so that we can then later on say, if you do have a shape where opposite angles are congruent, that it is a parallelogram. If you do have a shape that have opposite sides are congruent, you can say it's a parallelogram. These are the proofs that say it's true. So nice job. You're now all mathematicians, and you can teach class the rest of the week. If you have any questions, let Mrs. Obrist or myself know. Send me a Canvas message. I will be active on Canvas trying to pay attention, so I'll do my best for that. Conditions number 3 and 4 I will put into another notes video for tomorrow. Your only practice tonight is stations 1 and 2. So we're going to use the same 2 documents for the next 2 days. Okay. Same 2 documents for the next 2 days, but we're going to split it up into 2 days. All right. So again, any questions, let us know. I will see you guys, unfortunately, not until